ترى فاتح المايك. السلام عليكم ورحمة الله وبركاته. Thank you for the knowledge management team for having us, and thank you all for joining us. I am Talal Arayer from the Saudi Advanced Manufacturing Hub team, hosted by SIDF, and I would like to welcome you to this session, putting digital twin and AI in the context of industrial transformation and capability building, which is part of a continuous collaboration between the Saudi and Turkey Advanced Manufacturing Hubs under the theme of data analytics, process optimization in the era of Industry 4.0. Before we start, we want to have a safety moment. Please note that there is no evacuation plan for today. However, if there's an emergency, please follow the blue dotted line and note that we're in the second floor of SIDF's building. Once you follow the blue dotted line, it will lead you to the assembly points, and please use the stairs, not the elevators. And in case of an emergency, please dial 1113 on the landline. This event is a collaborative effort between the Saudi Advanced Manufacturing Hub and the Mixed Technology Center, which is considered as the Turkish Advanced Manufacturing Hub in Turkey. And today's session is not just a presentation, but a manifestation of our mission and vision, where we in the Saudi Advanced Manufacturing Hub strive to be a catalyst for enhancing the kingdom's industry towards advanced manufacturing. And this is done through a collaborative effort and a community that connects with the Global Advanced Manufacturing Hub network. We have set a bold agenda for the industrial ecosystem to embrace the fourth industrial revolution, and we are focused on practical outcomes and fostering a community that promotes the sharing of knowledge, best practices, and lessons learned. We believe that by bridging the knowledge and technology gap between the Saudi Arabia and Turkey's advanced manufacturing hubs, we can drive significant advancements in our local manufacturing facilities. This will not only improve productivity and competitiveness, but also push us toward a more sustainable and technologically advanced future in manufacturing. Now, without further ado, let's deep dive into the world of advanced manufacturing. I would like to hand over to our guests from Mixed Technology, who will present to us their efforts in advanced manufacturing. Mr. Rafi, the floor is yours.
Thank you very much, Talal. So I'm truly delighted to join such a distinguished audience today, and I would like to thank you for the kind invitation to SIDF to give us the opportunity to share some of the insights that we have collected during the first 3 years of operation in Turkish industry. So I would like to talk about, at the beginning, about MEXT a little bit, why we have established MEXT in Turkey, what was the motivation behind this, and how we are helping the Turkish industry in concrete terms, tangible terms, to drive their digital transformation. What does MEXT stand for? It is the technology center established in Istanbul 3 years ago by the largest employer association of the country. And there were two main motivations behind this. First and foremost was to make sure that the Turkish industry is keeping up with the technology trends and not only learn about it, but also help them deliver and implement this physically on their factories. So it's not just about getting some insights and getting some inspiration, but it is to provide solid technical guidance to Turkish industrial companies about how they should be driving their digital transformation journey. Secondly, we realized that it is of utmost importance to upskill people at large. So we need upskilled people, engineers and managers, as well as frontline employees who are able then to do those transformations on the ground. So those were the two motivations where we set out a couple of years ago to establish a state-of-the-art center. And I'm happy to say that within the first 3 years of operation since the inauguration, we have helped 400 companies in 13 different verticals of the Turkish industry. So we are not just helping a certain sector, but we are the designated go-to place, one-stop transformation shop in Turkey, and hopefully, inshallah, soon enough, we will be engaging with the ecosystem in the kingdom to also help companies here, and we will be discussing further potential for collaboration. Without further ado, I would like to give you some flavor of what Mext is about with a short video at the beginning. I'll talk about then some of the digital transformation challenges that we have observed on the ground in the Turkish industry, and some of this might also resonate with the ecosystem here. And then my colleagues will be giving you a couple of selected highlighted cases about the data-driven manufacturing, data governance, so some of the primary challenges that the companies are facing, and to put some context and real texture about digital twin and AI in the manufacturing context in Turkey. I know that such concepts are coming across as buzzwords some of the time, but there is some substance to it, and we can help companies to deliver those at their factories. And we will finish with the capability building subject, where I highlighted that it is of critical importance to accelerate this journey for the industry. So some quick impressions from the center in Istanbul. This is a 10,000 square meter facility, quite sizable, and obviously it is meant to welcome employees, managers, and C-suite leaders to come, witness, and experience how digital technology can help them to be more competitive, to be more productive, and more sustainable too. Of course, it is very human-centered oriented, so the curriculum that we have designed is appealing to all organizational levels. It has under the roof of the Mext, we are housing a state-of-the-art digital factory. We provide the digital maturity assessment services, the trainings, and the ecosystem, last but not least, refers to the partner network that we are matching with the Turkish industrial companies at Mext. So Mext signifies, what does it not stand for? It is the next generation of manufacturing. This is how we position ourselves. So we are not just serving a certain vertical of the industry, but it is appealing to the wider Turkish manufacturing community. Just a few words about the driving force behind this initiative. It is the largest employer association which established the center for the benefit of the Turkish industry. I need to highlight it is a non-profit organization, so there is a more, I would say, elevated objective behind this. And the association that established Mext has quite substantial history in Turkey, 64 years of history. 260 leader companies. You see some of the big multinationals as well as local companies who have a manufacturing footprint in Turkey. The association is an umbrella organization that takes care of their industry relations, and it was the vision of the association MESS to establish Mext for the wider benefit of the Turkish industry. So this is the, I would say, pitch sentence. This was our objective, to become a one-stop shop where any industrial company would be able to find whatever they need regarding digital transformation or sustainability transformation under a single roof. So is it just a training? No. Is it just a technology consultancy? No. Is it just a startup incubation ecosystem? No. It is the sum of this and more. So therefore, our biggest value proposition is to make sure that any company walking through the doors of Mext is able to find whatever they need regarding digital transformation. So let me give you a couple of impressions from the facility. So this is the 1,200 square meter digital factory, end-to-end digitally configured. This is not just a showroom, I need to highlight. It is a real working production environment where the purpose is to convince managers, engineers, and shop floor employees that there is a tangible benefit driven by digital transformation. So whoever comes here does not just get an superficial impression of digital transformation and use cases, but there is an in-depth training program behind this. And moreover, this is a live place which we keep updating with new technology every day. Just to give you a highlight, when we established the center 3 years ago, the number of use cases that were at display was 70. Now it is at 160. That means day by day basis, we are continuing to build upon our technology stack and introduce new use cases. Some of the highlights, this is in Turkey quite novel, the 5G mobile private network. So it's not commercial technology in Turkey yet, but it is in place here. Why am I highlighting this? Because our purpose is to show not just existing technology, but also show the glimpse of the future to the technology companies in Turkey too. I talked about the importance of the upskilling. There we collaborated with leading institutions, universities, as well as international companies like Fraunhofer, like Harvard University, to provide vision and leadership to the C-suite managers of Turkish industries. But also we worked with renowned Turkish universities like Istanbul Technical University to provide more in-depth technical trainings like data analytics, which is a very needed skill set in the industry. And we are able to, I think the last sentence is important, we are able to customize the training based on the actual needs of the customer. So it's not just an off-the-shelf curriculum, we can design and tailor the content and experience according to the needs of the customers. So partners are very critical to what we do. We believe in the power of partnership, and by design, MEXT was an open environment for collaboration. In the first 1.5 years of the establishment setup period, we went out to the entire world, from Singapore to North America and to Europe as well, and we sought some partners who would not only help MEXT to stay fresh with technology, but more importantly, the partners that we bring to the table are helping the customers in Turkey to drive their digital transformation. So you see some big global names like Bosch, Siemens, but also from Fraunhofer, Germany institution, but also the likes of Microsoft, SAP, McKinsey, World Economic Forum. All of them are partnering with MEXT to reach out to the Turkish industry, to understand their needs better and to engage in their actual project delivery. So this is the unique value that we are bringing. It's not just MEXT personnel itself, but behind us we have a cutting-edge technology ecosystem comprising global players as well as some of the cost-competitive local ecosystem players as well. And hopefully, soon enough, inshallah, some of those players are also willing to set up some local presence in the kingdom too. And we will be very happy to facilitate that effort. Startups are critical in that ecosystem. We consider them an integral part of the journey. And we would like to very much promote open innovation between industrials and startups. To that end, what we are doing, you see some pictures from our auditorium where we bring together cutting-edge startups, technology startups with industrial decision makers, and then they are engaging further to accelerate their digital transformation effort. So this is working very well, and we have been tasked by the Ministry of Turkey to also help some of the Turkish companies establish presence elsewhere and hopefully become unicorns. So we have also a duty to help Turkish startups to establish operations outside Turkey and become technology unicorns. Some of the partners, I highlighted already some of them, but some of them I would like to bring to the forefront. What they do, they are not utilizing MEXT just for the Turkish industry, but they are also basically positioning MEXT as a regional power. What that means, they are inviting prospective clients like McKinsey, Vodafone and Microsoft. They are inviting clients from Middle East, from North Africa and Eastern Europe to Istanbul to engage with their prospective clients. And this gives us also a higher level of visibility beyond the borders of Turkey. And hopefully we've started already doing work for neighboring countries like Azerbaijan, Romania, and UAE. And so we would be more than willing to also to do work for the service of the industrial companies in the kingdom here. So that concludes my overall overview about MEXT. I hope this has given you a flavor of who we are, what we do, and why we do it. And we will be at the end, of course, more than delighted to answer your questions if you have further questions about what we are doing. Before I hand over to my team, who will connect live from Istanbul to deliver their speeches about the topics I listed, I just would like to finish up with some of the digital transformation challenges we have observed directly from the Turkish industry. So this is a survey result that we completed at the beginning of our journey, and we worked with McKinsey to do this survey for the top decision makers of the Turkish industrial companies. What this means is that I think in Turkey, after several years of getting exposed to the concepts of Industry 4.0, Fourth Industrial Revolution, however you name it, there is an awareness already. So I think key decision makers are aware of what it is and how it might be useful. There is no shortage of awareness. There is awareness, but people are struggling to put this into real action. So this is where makes this helping them. What are some of the topics, issues that we are facing? So first and foremost, companies, although they might be aware, they don't have a solid strategy and tangible roadmap. So they need advice about where to start, what to prioritize, and where they need help. So they need guidance for that one. So therefore, I cannot overemphasize the importance of clear road mapping. This is where we as MEX are helping Turkish industry definitely. So some of the companies, less than half, have assigned some use case owners internally. So there are some trials internally ongoing on, some pilots and POCs here and there in the company. But then those use cases are not scaled. McKinsey calls this beautifully as a pilot purgatory. So the companies find themselves stuck in doing some local proof of concept studies without scaling the benefits to the wider company level. So almost more than half of the companies are stuck at this stage. And when you look at the down 13%, only a fraction of the companies are genuinely reaping the benefits of the digital transformation. So to basically take a look at the main challenges, we will talk about those during the presentation and knowledge sharing. There is certainly a business plan and roadmap issue, but data is the number one topic. Governing your data in a clear, structured way is the number one topic, which is the inhibiting factor of digital transformation. So therefore, it is very critical to get a data structure in place, govern the data correctly, not in silos in the organization, but in a very meaningful way. And this is exactly what we are driving right now in Turkish industry. We can talk about all the fuzzy concepts, like funny concepts like digital twin AI, but without having a solid data strategy, none of this would make sense. Therefore, we will talk specifically about this topic. Capabilities is a critical point. So you can invest in software, you can invest in cutting edge hardware, but if you don't have people who are able to interface with that technology with full knowledge, then you wouldn't be able to take the benefits of this. So therefore, we value the importance of upskilling and training people. This is exactly where is also makes this helping as well. Cybersecurity risks, definitely. So we have, when we approach those 400 customers in Turkish industry, we did see that there is a skepticism and concerns about cybersecurity, but then we are also giving them the right solutions to protect them against the risks of external threats. Last one, lack of coordination across business units. This refers to a more cultural challenge. So at least in Turkey, I can say that there is sometimes not a perfect harmony between departments within a company to work together. So after that, once we have seen this, we also started to provide agile transformation services to the companies in Turkey. We also started to give them design thinking capabilities to enable them to work together internally in a seamless way. So this, I should also highlight this because it's not just about technology and software and hardware. It's really the mindset of the employees and the whole company to drive this forward. So this internal collaboration is one of the key challenges where we are also helping Turkish companies to accelerate their journey. So hopefully this has given you some texture about how those 4 key pillars of MEX relate to what we are doing, because we believe that those are exactly the points that is needed by the industry. They need solid advice about technical maturity assessments for both digital and sustainability transformation. They need to convince themselves by seeing the value of the use cases in front of their eyes, how it makes an impact on the performance metrics. They need upskilling in form of capability building. And last but not least, they need to access best technology partners, solution providers, and those are exactly the 4 dimensions along which makes this helping Turkish industrial companies, and hopefully also soon enough we will have more collaboration with the kingdom here along those 4 dimensions. Thank you very much for listening to me, and now I will be handing over to my team based in Istanbul who will then deliver their presentations on those categories, and at the end I will be more than happy to take your questions. Thank you very much.
Selamun Aleyküm. I hope my voice is clear.
Yes, it is clear. Please go ahead.
Oh, okay. I'm Cenk Akgüz, the Director of Technical Consultancy Services at Mext, and I am generally responsible for digital and sustainability maturity assessment and also technical consultancy services. And thank you again to everyone for their participation. First, I would like to give a brief overview or diagnostic methodology for assessing digital maturity of the companies, manufacturing companies. Then I explain the details of manufacturing insights, especially at the automotive industry. First of all, we believe that digital maturity assessments serve as the starting point for companies on their digital transformation journey. For us, diagnostic methodology is Smart Industry Readiness Index, so called shortly as a SIRI. SIRI was defined by worldwide global consultancy partners like McKinsey, Siemens, TÜVSÜD, and people from academia, and it's internationally recognized by World Economic Forum as a worldwide digital maturity index. Until now, as a Mext, also FEB mentioned before, we have provided services to more than 260 manufacturing companies from 10 different industries, including automotive, white goods sector, machinery, steel manufacturing, but also textile, food processing, cement, refinery, pharmaceutical, etc.
Cenk, sorry, apologize. I think we are having some issue with seeing your presentation online.
Oh, sorry.
Maybe you can think about changing, swapping the page. I'm not sure. Mr. Talal can help.
Let me stop sharing and start sharing again. Is it okay now?
Yes, I think it should be okay.
Okay. And as I said, until now, as Mext, we have provided these services more than 260 manufacturing companies from 10 different industries, including automotive, white goods sector, steel manufacturing, food processing, cement, refinery, pharmaceutical, etc. In Mext, we have 12 SIRI assessors as our internal sources, and we have an ambitious target to make 500 assessments till the 225. The methodology is looking at 16 dimensions within 8 different areas in 3 building blocks to cover the whole manufacturing and enterprise processes. 8 key pillars which represent critical areas that companies must focus on to become future-ready Industry 4.0 organization, which are operation, supply chain, and product life cycle, under the process building block, automation, connectivity, and intelligence under the technology, talent readiness, structure management under the organizational level. Siri operational status starts with the onboarding meeting. After an initial briefing, the Siri assessor spends generally 2 days at the factory physically, depends to deep dive into each 16 dimension and set the existing status along with the prioritized dimensions based on the company's strategic plans. And with that, Siri provides an overview of the current maturity of the company. With benchmark tables, manufacturing companies could get comparable insight globally. At Max, we extended this methodology by providing 2 to 5 years transformation roadmap and also share prioritized use cases to be applied to reach the target maturity level. This is helping the companies to understand their bottlenecks and their transformation journey and get a prescription to accelerate the transformation. And also by having more than 260 assessments, as MX, we are able to understand the industry bottlenecks and propose solutions for those industries. For the industry bottlenecks, let's take the automotive industry as an example. We explore the critical bottlenecks in 3 key areas, which are scalability of pilot initiatives, supply chain integration, and data-driven decision-making. In the organizational building block, implementing Industry 4.0 pilot initiatives and scaling up best practice require competent leadership and a skilled workforce for scaling up best practices. In the process building block, end-to-end integration of the supply chain and fully digital production and integration into enterprise system are prioritized areas for automotive industry. I would like to give a detail in this section. The first one, real-time inventory management. Many automotive manufacturers struggle with the siloed inventory management system without seamlessly supply chain integration. And also they may face issues such as overstocking or understocking parts, leading to production delays and increased costs, etc. By integrating their supply chain processes, automotive companies can monitor inventory levels in real-time manner and make informed decisions to optimize stock levels and reduce waste. And also, second example, communication with suppliers is another issue. Automotive companies often work with a various network of suppliers. Each are using different communication methods and software. This lack of integration can result in miscommunication, delayed deliveries, and quality control challenges. By implementing a unified digital platform for supplier communication and collaboration, companies can improve transparency and the overall efficiency of the supply chain. And the technology building block part, bottlenecks are acting with real-time data in the production area and connectivity of equipment and energy traceability in the production and facility area. And as you know, traditional decision-making in manufacturing often relies on historical data and experience. However, in the era of Industry 4.0, real-time data from sensor and IoT devices can provide valuable insights into production performance. Automotive companies also that struggle to harness this data, with the help of data analytics and visualizations tools, allows business to make informed decisions promptly in a real-time manner, enhancing overall operational efficiency and competitiveness. The connection of facility equipment as well as energy traceability are critical consideration also, especially in the context of rising energy cost and pursuit of the net zero targets. Many automotive companies have committed to achieving net zero emissions as part of their sustainability initiatives. To meet these targets, it's essential to trace and manage energy use effectively through the production cycle. Without the right equipment connectivity and energy traceability solutions, tracking and reducing carbon emissions can be challenging for all companies, not also automotive companies, but all industries. By establishing a robust energy traceability system, They can track energy consumption across various production processes, pinpoint inefficiencies, and implement targeted improvements to reduce energy cost, and move closer to their net zero goals. They are mainly figured out as bottlenecks for automotive industry. And we also contributed to World Economic Forum white paper with our sectoral findings. If you're interested in more details about our studies, I would encourage you to download the white paper by reading the QR code on the screen. Here you can see the screen, I hope. And next session is data management and data governance. Now I am passing the word to Yasir, CEO of the Maestro Hub company, and he gives more details on Maestro and data governance. Stage is yours, Yasir.
Thank you, Cenk. Selamünaleyküm. Dear members of the ministry and manufacturers of the kingdom. Now I will be sharing my screen if I can get a permission.
I stop sharing now.
I am sharing now. I believe the screen is available for everyone. Okay. Have I also emphasized the importance of how we need to manage data? Anything that we will talk about from now on, AI, digital twin, requires basically three major components: a contextualized data, computational power, and profound algorithms. In order to feed this structure, we need to have a strategy in place where we can collect all of the data sources from IoT devices, website, web apps, microservices. Then we need to have a governance tool where we can ingest certain parameters in normalized fashion. Then storing those parameters in a central data lake, data warehouse, a historian approach, the algorithms for analytics data science can create patterns where we cannot see with human naked eyes. These adjustments will provide us dashboards, emails, notifications, and with this approach, we will be able to optimize our production in real time. The question for data science project, when it comes to data science project, which part of the work consumes most of the time? Well, there are several studies, but almost everyone agrees organizing and cleaning of the data takes more than half of the data engineers' time. Just finding the right data, creating these information packages to other systems takes a lot of skilled workforce time, which is unnecessary workload and reduces the return on investment for these projects. This is where we come in as Maestro Hub by creating a single source of truth industrial data governance platform. Basically, what our aim is creating a fully integrated business, a digital factory. The first step is we need to be able to connect and collect the data. Everything and everyone is plugged into network, not just the devices, the systems, or PLCs, but even the frontline workers provide valuable information, and we need to be able to capture this data in a common network. All of these should be integrated, not should live inside us, because we can only see certain parts of the business if we don't integrate all of those. So the layers of the business are integrated, and we have the current state of the business in real time. This helps us to have a historical data where it's already clean and contextualized, so we can make predictions for the future state of the business. We can leverage ML and AI technologies to run algorithms on our historical data, and future outcomes can be applied as an operational adjustment to improve the process, quality, carbon footprint, availability of the assets can be adjusted for almost any part of the business. And at the end of the day, we believe the stakeholders should have even though have recommended operational adjustment, should have the final decision, since it's not always easy to leave every decision to AI yet. It should be able to create operational adjustment, and we have the decision to execute or not execute on those adjustments. So most of the buzzwords, also FAB emphasize that AI, that we have data, we have AI, then we will create value. Well, it might look like that, but what it actually is, we need to have data sourcing, selection. For data science, the data engineer should be able to clean, normalize, feature engineer all of those data, create models, train those models, fine-tune. Then operationalization requires deployment, not just for a single cell or line. It should be able to scale to multiple operations across sites. So we have also constraints from security, legal, ethical transparency, where we are trying to solve, what we are trying to solve is minimizing all of those different parts where we have a single source of truth, industrial data governance platform. So your data can be already normalized and it's ready to be analyzed by AI. So I would like to open a little bit into this context normalization data. As you can see on the left side, there is an image where we just put AI. It says, since it has the stripes, it looks like a tiger. However, when you include the other data sources like shadow of the bars, then the AI can also drive that it's actually a dog, where the shadow of the bars fall on top of that. So this kind of data contextualization required for operational adjustments, where the AI can create actually real-time decisions where the algorithm has all of the information from several data sources. So it starts with data access. It starts with sensors generating 0, 1 or PLC tags. Then we give the unit of measure. Where is it coming from? Or for site visibility, is it a normal position? You might have a temperature sensor where it shows a high value, but according to your processes, it might be in the range of a normal operation. When you have multiple sites, you need to have enterprise visibility, comparing different assets in terms of their performance. So the value increases when you have integration, not just for different systems, but across sites, across value chain as well. This is a funny question. What is the actual cost of performing analytics? Even though most of the market study shows that it's less than 10 billion, actually we are spending more than $1 trillion to perform analytics, because we are not utilizing our data engineers, data scientists fully. We are spending more than 25% of the work on data discovery, more than 40% on preparation, and more than 20% on just governance. Basically, we are spending 1 unit of time to create analytics, but spending 6 or 7 times more on non-value-added activities. This is one of the reasons where the pilot purgatory exists, because scaling requires a lot of workforce. Rather than this approach, we create a smart data layer where you can connect your data sources with just a few clicks. And in real time, the system automatically contextualizes, transforms the data, which is already normalized and ready for ingestion for AI. Since everything is connected, we can provide data health insights if there are any deviations. And we are doing all of those with drag and drop, no-code technology. Your domain experts, your maintenance engineer, your method engineers can drive their own analysis by just drag and drop and completing all of those. Rather than left sides, where you are integrating everything from exponentially, like a sensor is integrated to PLC, to SCADA, then quality management system, to ERP, we say, why don't we just have, rather than this point-to-point integration, have a smart data layer where all of the data sources can communicate to it. This is a revolutionized architecture, which is really popularized in the last 3 years. Even Gartner acknowledged this architecture as the best scaling IoT infrastructure, unified namespace. And this is a broker technology where you can mirror the current state of the business from every source, and this becomes a node in all of those ecosystems where you connect and share information in real time. So unified namespace creates one single source of truth where all of the data is integrated into one data model. You have only one interface. You don't have one-to-many interfaces. Anyone can drive their own analysis rather than Excel spreadsheets. Now everyone can report their solution in real-time dashboards, and every application is running on the same platform. And this is the workflow, how we do it. We connect with more than 30 industrial communication protocols. We model the data to represent the real world, and you have the complete control on your data flows, when to send which data to which system. And all of those are mapped, organized in an ISA 95 structure, which also lives in the ERP systems as well. So I will share you the real-time data from Next as well. Can you see the ISA 95 structure as well? Or is it still on presentation?
We are still on presentation, yes.
Okay, let me stop sharing and share our Next environment. So this is what it looks like. As FAB mentioned, in 1,200 square meters, we have a digital factory where we have two different production lines, discrete production and continuous production. We have several lines like kitting, assembly line, machining, forming. We have material movements managed by AGVs, have an automated stocking and retrieval system for warehouse. And any data that you look for, it could be coming from a sensor like Kistler, lives in here, or cycle time from PLC, we can access those, or on our manufacturing execution system, we have operator details, their competency matrix, or even ERP data like what is the unit real-time cost of our raw material, energy consumption, or labor cost. Even direct information like, is there any line balancing problems in our production line? Or I would like to calculate scope 1 and 2 emissions, how many units energy consumption is currently happening. You can access all of those and map in a semantic hierarchy where you can just access like a shared folder approach. And these are living in real time. For example, we would like to get machine status details, the cycle time, design speed, all of them can be seen in real time. What is the work order? What is the gearbox ratio that we are currently producing? You can access all of those in real time. And by connecting with more than 30 industrial communication protocols, we do not leave any data behind. It could be living in files like Excel, because even though the digital maturity for manufacturers are improving, we still do business in Excel as well. So we need to be able to connect this to common network. Energy analyzers, PLCs, ERP systems like HTTP REST services, databases for big data analysis. We have message brokers, MQTT, and for even cloud providers, we have integration with all of those. And after the connection is established, and it's fairly simple, just like plugging your SIM card to your smartphone, you just need the name and host and port information, basically like your mobile phone number. When it's plugged in, then we can also browse everything if the protocol allows and import everything from there. And once this data is available, now any system can consume this data. For example, I would like to understand the cycle time and what is the current value of the cycle time, how it's contextualized with different data sources. Then I can read it in real time and it shows me its last part is being produced in 881 seconds. And we can also access the whole data lineage, how it's being used by different models as well. For example, cycle time is used for line balancing, energy utilities cost, machine status, carbon footprint calculation, and all of this data mapping allows us for AI to understand if we can improve the cycle time, all of these key parameters for the timeline balancing solution with the camera vision. So also where you can see whatever the status you would like to see. For example, for a line balancing, you would like to see the cycle time, the ideal design speed, which work position, gear ratio, gear type for Max, since it's producing a gearbox, work order number, and linking, or it could be for scope 1 and 2 emission analysis, like which operation number we are currently consuming electricity consumption for that production, how many parts have we produced, what is the emission factor for that process. And anyone actually without prior software experience can link this data, like cycle time is a reference from our connections. Let's put it here, double click, and you can just in real time validate the data you linked in real time. And you can see this is what it looks like. We have data sources, we have inputs coming from these data sources, have a snapshot of the time, which is already normalized and shared based on certain conditions. And this is where the orchestration comes in. You can send it to multiple data sources. You can send it in certain conditions. If an alarm is generated from the PLC, create a maintenance work order. If the maintenance work order has not been activated for or taken by any operator, let's look at the available operators, then assign those. And you can do all of those, again, like with drag and drop connections. I would like to send this in a NRS by Teams notification as well. And in real time, now I can share this information to multiple systems where the integration, usually before we had this infrastructure, took maybe 1 week. Now we can complete in minutes. Any system can consume this information, and in every 20 seconds, it will look and share this information. Since all of the data sources are connected, we can monitor everything, like what is the broken connections, like it's already shared me with an activity on energy spike as a payload from the teams as well. You can access everything in real time. And FBA also mentioned the onboarding, the capability building of the employees. We implemented a guiding procedure as well, where you can just say, I would like to connect with a Modbus TCP/IP connection, and the system automatically guides you through the related fields where it will be creating a connection, the VPN. If there are delays, I need to take this because it will send notification throughout the way. And it will automatically guide you through all of those and show you how to connect, how to create a connection. You can fill it in here, or it automatically auto-fills for you. You can write your standard operating procedures. You can access the document in real time. With this approach, anyone without highly skilled can actually use the data and drive their own analysis, create like dashboards, for example. I would like to understand the machine status or the deviation of the process parameters from auxiliary equipment. Is there any deviation that affects my production? Or for calculating the carbon footprint, I would like to understand what is the deviation between this time frame. Now it automatically can be analyzed, so the adjustment, this decision making, can be done in real time. Now I will pass the words for advanced applications like AI to Berkay on next, as well as what would be the challenges during that implementation. Thank you.
Thank you very much, Yasir, for this valuable presentation, all the detailed explanation for our data governance and collection, let's say. Let me to share my screen first of all. I think you can see the presentation. Selamünaleyküm to everyone. I would like to kindly thank you once again for welcoming us and for hosting this valuable session. So in this part, I will be giving some insights and information for the implementation of digital twin application in our Max Digital Factory, and also our initiatives on artificial intelligence in Turkey in manufacturing. But before jumping into that part, I would like to kindly briefly introduce myself. So my name is Berkay Yarpuzlu. I am currently working as the Partner Management Director at Max. I've joined the MEX team in 2019. It's already more than 4.5 years. And mainly I am in charge of working with, let's say, partners to help and increase the capability of our center regarding the technical solution ecosystem. Prior to this, I also worked for GE and Ford Otosan in Turkey. So now I would like to give you a brief overview of the digital twin and some examples of the use cases that we implemented in our virtual factory, let's say. I think as you briefly get how we govern the data, how we collect the data and make it visible, we can now talk about through our continuous line and discuss how we implemented our digital twin. Also, you can see in the screen. So for this part, I can say that we implemented Turkey's first virtual steel manufacturing facility, and which is powered by an advanced analytical model and algorithm provided by our two strategical main partners. One is Fortum, especially their E-side product formerly currently owned by Dovre Group, and currently we are more closely working with Dovre Group. But they are specialized in 3D imaging of industrial sites and operating plants to improve, let's say, project execution and performance. On the other hand, you can see Fives Feinstein from France. Fives is the company which stands as the designer and manufacturer of the machines, equipments, machinery, especially on the process side, and also the production lines for various process industries. So we had a chance to work with these two valuable partners for our digital galvanizing line in MEX Digital Factory. Before jumping into the details of our digital factory and digital twin, I would like to give a brief explanation about this, let's say, process optimization. As Yasir Bey mentioned, of course, and also Efe Bey mentioned, it is quite valuable and it is kind of mandatory to collect the data and make it visible before going, let's say, further on implementing the advanced analytics algorithms for increasing the optimization level of the processes. And top of that, by using these algorithms and, let's say, correlated models, we can also implement some machine learning mathematical models to control or to increase the model predictive control systems. And top of this, we position the digital twin applications. But as a fact, I should say that in the process optimization journey from advanced analytics through the digital twin, the value and the both the value and the difficulty of implementation increases dramatically. So this is important because, of course, we need to start with data governance, but we also need to be aware of the this behavior, among from advanced analytics to digital twin. And also before giving some details, I would like to start with a very brief and very short description of digital twin, because today, as you are also aware, most of the companies are mixing the digital twin approach with the digitalization of the data. But of course, it is not that simple. Digital twin, especially for these kind of applications, simulates the production process and enables testing alternative process settings, different configurations, different parameter sets. On the other hand, with that, it is also possible to find out the optimal parameters or process settings for the physical line, and it also enables to automatically transfer all these kind of configurations to the control systems. And more importantly, you can, if you have a meaningful digital twin model, you can perform all these kind of activities without interfering the production itself. But at the end of the day, somehow you need to create the virtual environment in a linked way with the real work processes, and these should be in a closed loop. So by this way, you can directly feed your virtual environment from the physical world, and also you can share the output of the virtual environment as an input for the physical world to increase the efficiency or to optimize the processes. Of course, the digital twin applications comes in many forms and functions. Here you can see different parts of these kind of applications, but I would like to start with the shadowing and difference between shadowing and digital twin. So with these kind of applications, the product management, asset management, process management, or also the, let's say, factory layout designs can be optimized either having a shadow or digital twin, but digital shadow is a bit different than the twin, which is the digital representation of the current state. And it is mostly used to track and analyze the existing situation. On the other hand, the digital twin is the complete digital replica of the physical system. And we can think about, like, we mainly use these kind of applications to simulate different scenarios, different set parameter sets, different configurations of the physical system. But as a fact, again, the underlying digital model should be highly dependent on the application and the expected outcome from our physical world. But again, you can see different applications. You can focus on a product level. With these kind of shadow and twin applications, you can focus the virtual prototyping side or product optimization. On the other hand, you can directly perform the asset management, asset monitoring and management, let's say. And by this way, you can use some maintenance applications or asset optimization applications. And for the digital process shadow, on the process side, if you would like to directly focus on the quality of the process to ensure the quality of the product, we can use these kind of real-time information systems to also monitor our processes, monitor their conditions, and also optimizing the processes themselves. And at the end, we can directly implement the digital shadow or twin of the line itself. So these kind of applications usually helps us to link the manufacturing or processes directly with the enterprise level, and this can end up with some applications on the scheduling side, or directly you can do, you can take initiatives for your factory layout, factory design or layout design. But before doing this, I would like to mention that for a digital twin, we need three different components. The first one is the physical system. Here you can see the physical world, which involves actuators, sensors, PLCs, mechanical equipment, machinery, these kind of things. On the other hand, we have virtual model, virtual environment itself. So this is a part of the physical system, but this involves again the production, chemical, or even electrical models. But this should be, we need to be very careful, because these virtual models, as a must, needs to be some things, an application which is a data-driven one. So we need to link the physical world and the virtual models with the data, and this data connection between these two components can be the inputs and outputs of the specifications from the physical world. But more importantly, again, you can see in this presentation, in this page, there is a closed loop between the virtual and physical environments, because whenever you want to see the outputs of your line in a virtual environment, you need to feed the virtual models with data. About the benefits of the digital twin applications, especially in manufacturing, these benefits can be classified under process development, process planning, process control, or directly, this is very important, by the way. FAB also mentioned the importance of the capability improvement activities. So these kind of virtual environments can also be used for the training activities. So this is also important. But to be able to get these benefits, First of all, we need to connect the real world with the virtual world. And these inputs, you can see the enterprise level, the ERP systems, MES systems, SCADA systems, and any kind of sensor data or PLC data. These should be directly merged in digital twin in a right way, because at the end of the day, these will be the reference data, but in parallel, we should also understand the right simulation model parameters to have a highly correlated, at least a correlation in a meaningful level between our two different environments. So of course, in our digital twin, we can do any kind of simulation from mechanical to electrical, and afterwards we can directly take the data to see the benefits of these kind of applications. Now, I would like to briefly talk about our application in Max Digital Factory. So basically what we build is the digital twin that can be controlled with a single control room. Here you can see we have the virtual level, we have the physical level, but again, there is a closed loop here. We are controlling our virtual world via a single control room. These, especially the critical ones, like the ones in the furnace part and etc., use different materials like videos, drawings, I don't know, the factory CAD data to increase the realistic level of the virtual world. And we also include all of the critical equipment in this input material parts. And with all these, with the help of Fortum's, let's say, expertise, we integrated different components like the 3D VR environment. But I would like to mention that the digital twin part, the digital factory part, is not just an animation in Max Digital Factory. It is a kind of a real virtual environment. We use Unreal Engine, gaming engine, to design all of the functionalities like interactions, storyboards, scripts, timelines. So we can say that this virtual world is a living world. We can directly modify whenever we want. We can put another, further machinery, or we can directly take away the machinery. So I can say that with the combination, at the end of the day, we have a digital twin and a 3D environment for our digital factory. So for our initiatives on the application for digital twin applications, let's say, I would like to briefly give some examples on the use cases. But before jumping into that part, I would like to briefly give information about how we can read these one-pagers, the details here. So here you can see we briefly identify the problem, solution, and impact on the factory, on the facility. Then you see application areas here. You see only 6 AI application areas. As AI applications can briefly be categorized into those 6 categories, but this can be increased in the future for sure. So there you see 2 technical information. First of all, the first one is the confidence level, which can be stated as how successful is the model. As we have some, let's say, under integration and optimization use cases as well, you may see sometimes non-acceptable level for manufacturing. On the other hand, the ML algorithm on the right-hand side, briefly to give you an overview of what is currently being used. Here you see KPIs to assess the success of the application. In the bottom or middle of this page, you can also see some indications for ROI, scalability, and implementation speed. So these are the important things, quite important things, before deciding to implement the application in the facilities. So I would like to start with our first use case, which we implemented supervised learning in the digital twin line, is the demand forecasting. Here you can see, I would like to briefly give the problem statement. The problem was that a significant challenge of manual demand forecasting is the lack of flexibility, which is crucial for the companies which need to adapt quickly. So manually created forecasts cannot be made on the go, and after a few weeks, months, once additional real-time data is involved, it is even inaccurate. So the solution is here. The model can combine multiple internal and external impacting factors, promotions, market plans, trends, etc. So by using this information, the prediction models can be introduced, and for future trends, the overall demand or demand split by SKUs can be forecasted. So, and we can see that the impact is, of course, the demand algorithms based on accurate modeling can help the companies on decision making, and this would also help the increase the efficiency and efficiency in supply and production planning activities. So currently, this line is still under the optimization process as it has only 75%, as you can see on the right-hand side in confidence level. But we can say that it pays very quickly, although the average implementation speed and scalability. The second one is reducing the zinc excess coating with using advanced analytics, which is quite important for this kind of continuous processes, because the problem is here mainly the configuration of the process control parameters. They are being manual, and most of the time zinc coating process parameters are, has an inefficient consumption problem of zinc, which is valuable material for the coating processes. And if you also if you consider tons sheet metal, this means a lot of money. So the solution is using advanced technologies to monitor the control systems and using analytical algorithms, closed loop algorithms, to see to track the surface of the sheet metal, and using the interdependency between the correction rolls and pressure of the air blades to get rid of the excess zinc coating. So which is really valuable for these kind of industries. And for the impact, we can say that this helps to identify patterns and trends indicating the coating process produces excess zinc. So the confidence level is quite high because we are implementing the physical hardware, we are doing the real-time monitoring, etc. Here you can see the other use case, model predictive control to maximize line speed. You can see the details again in this presentation. Since we have a quite limited time, I would like to go to our second part, but I would be more than happy if you have questions, or we can directly talk whenever you want. We can organize separate meetings to be able to explain what we have done for our digital factory. And in the next part, I would like to briefly mention on what we have been doing for the AI initiatives in manufacturing at Next. I hope, first of all, you all get a brief overview of the digital twin and some examples of the use cases we implemented in the digital factory. But now I would like to also give you some details on AI activities. So before going to this work, would you kindly guess what percentage of the companies believe AI generating financial benefit for manufacturing? Let me to show you, based on MIT's long global survey conducted over the last 4 years, more than 3,000 companies. The companies recognize the business imperative to improve their AI, let's say, competencies. 70% respondents understand how AI can generate business value. Almost 60% have an AI strategy in place. 57% affirm that their companies are piloting and deploying AI, and 10%, despite these trends, only 1 in 10 companies, let's say, believe they generate significant financial benefits. But we can say that what would manufacturers need from AI we can say that there are three parts. One is the explainability, the other one is the reproducibility and trustworthy. So that means today, even today, we are, yes, these may be sometimes fancy words, digital twin or AI, but we all believe that these can be changing our way of doing things. But to be able to that, at the end of the day, we need to have highly, let's say, trusted structures or algorithms or softwares to be able to merge in our systems. I would like to give the main challenge hindering in adoption and scaling of AI applications in manufacturing. First of all, there's a mismatch between AI capabilities and operational needs, and the absence of a strategic approach and leadership communication is quite important. We also have insufficient skills, data availability, and a lack of explainable AI models in manufacturing. So to be able to understand the AI models further, we need to invest in our skill set matrices. So as again, FAB mentioned, we cannot directly separate the manufacturing from the culture and these kind of skill set matrices. But at the end of the day, these kind of applications today still need some customization efforts across manufacturing use cases. So we need to first of all solve these customization efforts and make it as a product or introduce these kind of applications as a product. So in this page, I would like to give a brief information about our inspiration, let's say, by getting an inspiration from this framework. We initiated a global project called AI in Manufacturing in the World Economic Forum. So this project is initiated with the support of two different platforms of WEF, the Advanced Manufacturing Platform and the AI and Machine Learning Platform. And in this project, we listed the selected use cases to showcase the manufacturing use case in AI and roadmap for scalable AI use cases. If you want to see the details, you can download by scanning this code. In December 2022, we also published a white paper over this. I would like to show a very short video, 1 to 2 minutes, for the organization that we hosted as MEX in 2023 in MEX Digital, MEX Technology Center. Thank you. Again, we can give further information whenever you need, whenever you want. And here in this page, I would like to explain a bit more in detail what has been done with this, let's say, white paper. In this white paper, 23 AI use cases were collected from 35 companies in 6 application areas. As you can see here, maintenance, production processes, supply chains, energy management, quality and health and safety, and you can see the vertical pillars for each relevant topic. But I can say that this study mainly provides value in 3 specific categories. First one is the operational performance. We are saying that these kind of applications directly or has a direct impact on increasing the operational performance by touching the throughput, quality, business uptime. Secondly, again, there is an increase in workforce augmentation because these kind of applications can be directly used as a support mechanisms for decision making, or you can increase your collaboration level or prediction and forecasting level, accuracy level by using these kind of applications. And the last one is and more importantly, which these kind of applications directly supports, even leading for sustainability initiatives, and you can use these kind of applications to to increase the material efficiency, energy efficiency, scrap rate, scrap management, even waste management. So these are important topics which is included in this white paper. But besides to implement those use cases, we believe that we have a phase structure like 4+1, which is required. In phase 0, on the strategy part, a well-governed data structure and building a skilled team are the main requirements. So here you can see we need strategy, we need data, we need team setting or capability building for our workforce. After the company is ready to begin, the use case pre-selection with some ideation sessions will help to choose the right focus. Following this, the company's AI readiness level with the selected use cases must be assessed, mainly focusing on 4 different, let's say, categories: infrastructure, data, production process, again, mindset and culture. We need to do these kind of assessments very carefully. In the third phase, the use case feasibility must be assessed from different aspects, because this change differs to address the right use cases, and they need to support this with the data and testing and scouting. Finally, the first pilot must be implemented to see the success. This is an important thing from the cultural manner to motivate people and also to see the functionality of these kind of projects. And on our side, as Next, we want to support the industry again with 4 pillars regarding AI in manufacturing. The first pillar is the infrastructure. Here you can see we already have end-to-end connected digital factory from which we can collect data from different areas. And also we are currently adding extra muscle, we already added, to empower AI applications with our very strong GPUs for AI workloads. We are currently using the A100s as GPU systems. Secondly, we designed the specific AI training modules. Merve will be also giving the details on the capability building side, but we can say that until now we upskilled more than 140 employees, and soon, currently we are working to initiate new journeys for even C-level adoptions. So third, the services. Currently, global institutions like McKinsey, Fraunhofer, Koç University, and many others already start to recognize Next and start to use our global test bed for AI. And anytime you are more than welcome to use and contact us if you need any kind of test bed for your applications. We are always more than happy to open our doors. And currently, we are selecting our use cases to position in this area with the help of our technical team and also focusing on startups. So our main purpose is to work to create scalable pre-trained models for common industrial problems that we could solve with AI. And our global partners, again, you can see there are strong parties, Quantum Lake from McKinsey, Microsoft, especially with their Bonsai product, AWS machine learning, IBM is close, and the national institutions like Istanbul Technical University and TÜBİTAK Bilgen from Turkey. Lastly, my last page, I would like to, these are again our use cases, but I think we don't have time to talk each and every one of these, but I would like to give a brief understanding of what we have in our digital factory. You can see on the right hand side, we have our discrete line. On the left side, we have our continuous line. But we already implemented different use cases where, like AI for personal protection equipment check, here you can see, or automated beam picking. I already mentioned a couple of the use cases on the continuous side, but on the discrete side, again, the supplier collaboration on PLM, which drives the CNC machine loading and unloading operations, is a quite important use case. And also we are also focusing not only the machinery and equipment. Besides, we also believe that the digitalization of the front end workforce is quite important. So we focus on the digital round, audit SOP, or smart wearable applications, these kind of applications to stream real time, also the manual operations. So this is all from my side. Thank you for listening me. Again, please just kindly let us know if you have any further questions on these kind of digital twin and AI applications. I would like to give the stage to Merve for our capability building activities and initiatives.
Thank you very much, Berkay. I hope that everyone is hearing me. So I'm gonna share the screen now. So you see my screen, right? Okay.
Merve, maybe
Yes.
you can just swap from the display settings. I think currently we see the other
Sure.
on the top.
Just a second.
You can click
Yes.
You can swap.
Okay, now I think it's full screen, right?
Yes.
Okay, great. Hello, everyone. Merve. I'm working in Max as Learning and Development Director. Now, the last but not the least, I would like to explain Max capability building programs. But rather than the details of the services, actually, we would like to share a few of use cases and what I can say as case studies in terms of the capability building programs. But before going on 3 case studies, first of all, I would like to give a brief information about what we have done up to so far. So currently, we have reached out almost more than 15,000 people in Turkey. So most of them are field workers, operators. The rest is the white collars. What we mean is the white collars, standing from C-suites to mid-level managers, and after that, engineers in different industries like oil and gas, metal industry, cement and textile, or FMCG or pharma. So in total, we have reached out to 15 different industries and more than 200 companies. So we are always paying attention to the retention and the pleasure ratios of NPS of the participants. For that reason, actually, based on the feedbacks that we have been receiving from the field and all the participants, we have been updating the content and user experience side of our training programs. So while we were designing the programs, actually, we have started to design the programs with Harvard University or RWTH Aachen University and the biggest universities in Turkey. So what we are doing actually currently is to be able to bring the academic knowledge of the world together with the industry's knowledge in that country. So first of all, I would like to explain a case study from automotive industry. Tofaş is one of the biggest automotive companies in Turkey. For 2023, they have defined 6 different pillars in digital transformation in the company. One of them is RPA, IoT, business intelligence, data science, low code and no code. What they want from us to prepare and design and execute a program based on an upskill and reskill challenge. So for that reason, we have been calling it level-based technical expertise programs. What we mean is that, first of all, let's say that a person who is working in HR may not have to be in the level 5, which is the highest level. Level 1 is the awareness level. So, but another person who is working in IT is expected to be in the level 1 in data science, let's say. For that reason, when we think about the company, which is almost 3,000 people, actually we have defined who needs to be in which level and who is currently in the as is situation. So as is situation and to be situation in the last day of the year. So based on that, we have defined not only the trainings, but also some development activities like a workshop or mentoring programs to be able to bring and upskill people in different areas or reskill people in these 6 pillars. At the end of it, actually, we have touched almost 1,000 people in the company. And especially we have started the training from the C-suite, then the mid-level managers. First of all, in the curriculum of the program, there were a pillar which how to lead digital transformation. Then we have moved to technical expertise programs. At the end of it, we have really paid attention to what the company is using in the field. Let's say that in IoT, or in image processing, if they have been working in Cognitive, which is a company in Turkey, then we have defined that technology and we have defined the development activity with that companies and the field work in the especially field. So at the end of it, we have delivered almost 64 and 33 training sessions. Then indirectly we have reached out to 1,000 participants at the end of it. So why we are calling it as an upskill and reskill is currently they may, for instance, the people in level 4 are really capable of using Python, especially in data science programs in their company. Then the second case study is from an oil and gas industry. It's a change agent program. Actually, some of the companies do not prefer to progress with less defined mid-level managers and give trainings to all mid-level managers or engineers. They would like to select, let's say that 40 or 25 people from their companies, horizontally and vertically, who are presenting the company in all different departments and in all different titles. What we mean is that, for instance, in the change agents programs, there are also field workers, operators, and also C-suite, whom we mean is CD or CTO in the company. Then after that selection process, actually, we have defined the program with 3 main pillars, which is digitize yourself, digitize your community, digitize your business. Why we have selected those pillars? Because first of all, in order to be able to implement digitalization in your company, first of all, you need to change your way of looking and your mindset. And the second one, you need to communicate with all the people in the company, especially who are the experts of different areas like RPA or IoT. And then you may start to digitize your business with the learnings that you have learned. So they have opened the application, and almost 180 people have applied, and they have selected 25 people based on some of the digital transformation change agents capabilities that we have defined beforehand. Then before we have started the trainings and development activities, currently we are just applying development center. It's a one-to-one capability conversation with the people that who are going to be expected change agent at the end of 8 months. So based on that, we have defined a digital competency framework, which is including communication, collaboration, or core IT skills or knowledge. Then currently we are also measuring their as a situation, as we have been defining in Siri, for instance, for a factory, we are defining as a situation of the people in terms of their capabilities. Then after that, we are gonna start training and development activities for 8 months. First of all, last year's GND, so what I mean is the change agents, people are going to be mentors. Today's change agents are going to be mentees. So they have been meshed to be able to learn from each other, which is a core pillar in adult learning. And after that, we are gonna start with leading digital transformation with some different kind of modules, like how to understand what are the pillars of digital transformation, how to execute it, and how to lead it. Then some of the social skills, which is like design thinking to be able to core problem or the core challenge of a problem. And after that, innovating thinking to be able to solve the problem with human-centered approach. Then C-suite round tables to be able to boost top-down to bottom-up approach. Then the technical topics that covered during the program, like AI and ML and hyper-automation or cutting-edge tech, and all the other technologies that we are gonna cover during some different kinds of development activities and trainings. While some of them are in-class trainings and led by an instructor, some of them are self-learning activities, like the trainings delivered by LinkedIn Learning or Coursera and so on and so forth. So it has been defined by taking the pillars of an adult learning. At the end of 8 months, we are gonna again make a development center activity to be able to measure ROI. So how the people have progressed. So how the progress has been with the 8-month investment to the people. So in order to be able to ensure that we are gonna make an increase at the end of the day, during the program, in some milestones, we are gonna approach the people to be able to show that how it's going, how is their learning with some pre and post tests, to be able to measure that it's going well, and so they can apply and implement their learnings into their business. So this use case and this case study actually is one of the programs that we have been designing in company suite or an organization specific. So for that reason, we can also call that is an upskill and reskill program. The last but not the least one is again change agents program for an automotive industry. They have also defined some 47 people from the whole company who are from C-suite and also the operators level. So at the end of it, rather than those kind of technical expertise program, we have defined some project management and digital fundamentals level. What they are doing differently is that they have been defining the problems in the field. So let's say that someone from marketing and sales team would like to use CRM, but if they are not so capable, the people in their department is not so capable of using it, then they have been just measuring and collecting all the problems that they have been choosing. After that, they are learning how to solve it with this program. So at the end of it, they have reached out to 80% success to be able to solve the problems that they have defined in the beginning of the program. So this one, as differently than the other, rather than measuring the people's capabilities, it's more focused on the measurement of how we have progressed and how we have accelerated digital transformation in the company based on the pain list we have defined at the beginning of the program. So this is another case study from automotive industry. So in short, actually, thank you very much. I would like to thank you all the people who are listening to us. So in short, I can summarize. We can design customized, and so based on the level, so based on the C-suite and so operators, mid-level managers and engineers level programs, and industry based programs based on the need of the company or organization. Thank you very much.
All right. So I would like to thank you, everyone, for your patience. It has been a very intensive session with a lot of information in various topics. But I hope it has given you the general feeling that those intensive subjects can be well managed. It needs fundamental basics. So I think one key takeaway message from the session should be, I hope, was the data governance is at the heart of everything. So whilst we are talking, fantasizing, hoping for the benefits of AIs and digital twin, it all starts with having a solid data governance structure. So without achieving that, one can only simply talk about digital transformation. But hopefully you have got away the key messages that those challenges can be successfully addressed. We have solutions for that, not only technical solutions, also we can show the way how this can be achieved, also in with regards to training and cultural transformation. So with that, again, thank you very much for this opportunity. So we very much appreciate this occasion to share our knowledge that we gathered within the first 3 years of the operation. And we are looking forward to an exciting future here in the Kingdom with yourselves. Thank you.
We'll open the questions for the audience. Please go ahead.
Please, sir.
First of all, I would like to thank you for the insightful presentations. I know it's dense, but we got a lot of information. In this IDF, we have an experience in making a change in the factories. And we adapted this year the Lean Manufacturing Program as a program, and we in that program, we started to implement the analysis and the diagnosis that we identified in the factories. However, we felt there is a difficulty, and in the beginning of the presentations, you mentioned the business units internally in the companies, how you convince them that this is the target and this is what we should do. So my first question, how you worked with the companies in order to overcome these obstacles which are internally? This is the first question. The second question, you talked about the 260 assessments. I would like to ask, have you diagnosed or from your analysis, you found some sectors are more appetite to the digitalization and the automation more than other sectors? And I have a third question, but I will leave it after.
Thank you. Thank you. Very good questions. So regarding the cultural challenge and how to convince companies to work seamlessly with each other internally, I think what we are doing is that we are encouraging them to set up a digital transformation office that is cross-functional, not only governed by IT. It should be definitely a collaboration between IT, manufacturing, supply chain, just to name a few. We encourage them to establish a digital transformation office, and then that digital transformation office should oversee a set of small teams, again cross-functional teams, with very well-defined objectives and key results, and let them work in an agile way. So whilst the huge company may not be able to transform instantaneously to an agile mode of working, we encourage them to take job. IT says, no, this is my job, whereas in reality, it's the two of them. They should be working seamlessly with each other. So this is a good way of getting them to the habit of delivering agile projects in digital transformation. This is what we are encouraging, and we also provide also design thinking sessions to give them the habit of innovating together. So the teams will certainly face challenges when they embark on projects, and they should be able to figure out a way of resolving those challenges. And design thinking offers a good methodology for cross-functional teams to innovate together. So I would say, in answer to your question, first question, we give them a flavor of agile transformation, not at the corporate level, but in small steps. And secondly, we supplement this with design thinking methodology to enable the teams to overcome challenges, innovation challenges themselves. So those would be my two answers to your first question. And second question was, which sectors are more receptive to digital transformation? Certainly in Turkey, we have seen automotive industry was at the forefront. This is actually why we have presented the case study about the auto industry. And what we are seeing is that if there is a pressure on the industry to come up with resilient and responsive supply chains, those are the ones that are more keen to drive digital transformation. So in the case of auto industry, it's a very competitive industry globally, and therefore there is a push to transform quickly, not the OEM itself, but including the supply chain. So those sectors where it is even from competitiveness perspective more key to transform quickly, those are the more receptive ones. Likewise, textile, for example, is another industry in Turkey where sustainability is an imperative. So Turkey predominantly exports to European Union, especially for textile industry, and there is a huge push from the consumer side in the EU to disclose environmental social governance metrics, ESG metrics, to disclose genuine efforts for decarbonization. Therefore, what we see there is textile is now a lot more receptive to sustainability transformation, for example. So I would say those industries which suffer from competitive pressures and other consumer-related trends like sustainability, those are the ones which are more receptive and keen to press forward with initiatives. Those are the ones where we started initially, and step by step we are extending our work to other sectors of the Turkish industry. Hopefully that makes sense.
Thank you, Effie, for your answer. We have time for another question.
Well, thank you for your excellent presentation.
Thank you.
My question is related, do you provide a turnkey solution or just a roadmap? The second question, you have presented multiple cases, the digital twin and advanced analytic. And very interestingly that you showed that the payback period or the return on investment is 2 years. Can you give us range about the capex or the total cost of these investment?
Certainly. Regarding end-to-end delivery, yes, there are examples where we as Max directly help our customer in their end-to-end journey. So there are cases where we directly provide implementation support with vendor selection, technical blueprint, design of the solution, including the integration aspect, and also oversee the hands-on delivery on the site. So we do also hand-holding exercise as well, if it is required. But definitely, there is a certain capacity that we can allocate to this from our end. In most of the cases, so there are examples in oil and gas, in chemical industry, in Turkey, in textile, and in auto as well, automotive industry. But we are very selective in terms of which customer to choose, because as you can appreciate, those are very, I would say, labor-intensive discussions. So you need to spend quality time with the customer for hands-on customer delivery of the projects. In most of the cases, we bring along our partners who would provide support for the on-site delivery. But if it is required that we act as digital transformation office, as an external consultancy, the answer is yes. Yes, we do oversee end-to-end project delivery. In most of the cases, as a digital transformation office, but where it makes sense for both of the parties, then we can also provide hands-on the site delivery support too. Your second question was about CapEx requirement. This is varying significantly, but in most of the cases, when it comes to digital twin type of implementations, so in bigger industries, yes, we are talking about a couple of $100,000s, definitely. But what we are trying to do is, especially for small, medium-sized enterprises, to increase their appetite with quick win projects, where it is not mandatory to spend that amount of money, where they can already see some solid benefits, bigger return on investment with smaller amounts of investment. So in most of the cases, in auto suppliers, in textile, in food processing, where the players are relatively small and medium size, I wouldn't say we are talking about a couple of hundreds, more tens of thousands of dollars to get them started, to see some benefit. And definitely the incentive scheme in Turkey, supported by the ministry, is helping with favorable financing, also providing certain tax benefits. Those are the things that are now facilitating the overall transformation. So I would summarize as start small, not huge capex investment, see the benefit, increase the appetite of the key decision maker, and then start investing in substantial amounts. Thank you for the question.
Yeah, I hope my voice is clear. So I am Mohammed Shamrani. I am part of the IT team. So in my previous companies, I worked on digital transformation projects. We faced two challenges. One is to convince the manufacturing to sit with us, because in their opinion, hey, I have a plant, I have a deadline I need to meet. So this is one challenge, and you correctly explained the data office or the office that will gather them. That could be a solution. The other very challenging part, that as an IT, we understand machine learning, we understand how to gather data, but we are lacking one very critical knowledge, which is the business itself. And it was really challenging to gain this knowledge. How do you suggest to overcome such a challenge?
Yes, definitely on the first one, I fully agree. IT and manufacturing, those are typically two departments that sometimes have these internal quarrels about who should do what, and therefore having this cross-functional transformation office definitely helps. And certainly, if the key decision maker, like the CEO, Chief Executive Officer, gives a clear mandate with very measurable metrics and holds those two functions accountable for it, then things are moving faster. In most of the cases, sometimes we see that companies do digitalization for the sake of digitalization. This is nonsensical, obviously. It should serve a real purpose, and the CEO should have some tangible, measurable results in mind when initiating such transformation projects. In that case, if there are KPIs that two departments are accountable for, then things are moving automatically a bit more seamless, I would say. And the second question was, if you could remind me, IT and function understanding each other, right? Especially the domain. I can only advise to start with this diagnostic methodology, the maturity assessment methodology. The Smart Industry Readiness Index that the Kingdom is also here promoting within the industry certainly takes a look at this challenge and whether the departments understand each other. It certainly helps to have an outsider perspective, to take a fresh look at the situation, and then make this diagnosis on behalf of you. If IT and business, manufacturing, or supply chain are not adequately talking to each other, having an outsider view gets them on the same table, I would say. And upskilling programs, definitely. The change agent program that Merve, as the last presenter, presented, is bringing those two departments within the same cohort of change agents. So they are sitting side by side, they are listening to those education programs, and we get them to talk. So again, as an outsider, in this case Mext in Turkey, we can help promote that dialogue, facilitate that dialogue, internal dialogue too, in carefully designed and curated workshops and training programs. So you are absolutely right. It requires a little bit of push and facilitation from outside, I would say. Thank you.
Assalamu alaikum.
Alaikum salam.
I am Ibrahim Al-Numai from King Abdulaziz City for Science and Technology. We are actually a research entity, and we are improving models in machine learning, deep learning, and recently in ChatGPTs. But actually, we are facing, I believe, a core problem that we don't have the data. We are doing, I think we are doing some research in the preventive maintenance, inventory tracking, for example. But unfortunately, we are just using artificial data. We are collecting from repositories here and there. So you, from your experience, and you mentioned it at the beginning, you said 60% of the time how to collect and process the data. From your own experience, how could a research entities could overcome that problem?
It's a good question. I have an example with a big automotive manufacturer. They are doing a European Union funded research project, and they were lacking data. And in that case, for example, they are using Mext as a testbed to generate data. For example, the CNC machine that you have seen in the videos is now generating, in carefully defined conditions, data for the automotive OEM to work on their models. And you are absolutely right, they have huge facilities which they have to operate on a day-to-day basis, and sometimes they struggle to collect and find data. In that case, we as a interface organization are helping them to generate data, not synthetic data, but real data that would allow them to feed their algorithms. And another example, I would say, so this is a solid case, and sometimes it is meaningful for them to collaborate with each other. So hopefully we will have some consortia projects in Turkey, for example, where we will collate data from various industries to come up with predefined, pre-trained algorithms. You are absolutely right. If every manufacturer is trying to go and come up with an algorithm for itself, it would require it would be a waste of effort for everybody. So what we are trying to do instead is to have pre-trained models for the industry, semi-cooked solutions, so to speak, which then they can go and feed with limited data to start benefiting from those models. Take the case of injection molding, for example. It's a hugely complex process, and in order to model it well enough, you would need a lot of data, so which none of the manufacturers has. So what we will do as Mext in this case, we will try to collate data from various industries ourselves, have a predefined model, and serve this as a basis to the industrial companies, which they can almost like, it wouldn't be turnkey plug and play, but they would have something to start with, which they can feed with smaller amounts of data and start benefiting from the models, if that makes sense. So first, we can generate the data as an interface organization to them for research purposes. Secondly, we can collect data from various players and come up with predefined models that would enable quicker deployment of AI solutions in the industry. Thank you.
Hi,
Maybe you had a third question, but yes.
Yeah, I'm here.
Sorry.
So my name is Parvez Akhtar, and I work as a market expert in logistics, supply chain, and data science itself. And my not concern, but want to know your comments on this one. One of your pillar was about upskilling.
Yes.
First of all, thank you very much for this interesting thing you presented, from end-to-end solution, collecting data, then driving insights from analytics, which was very interesting. So one of the pillar was upskilling.
Yes.
You will normally face a lot of challenges between culture, particularly for non-technical people. When you're upskilling non-technical people and trying to upskill them through technical knowledge or technical skills. So this is one of the challenges which I have seen over 20 years of my experience from academia and industry. Before coming here, I was a professor in University of Aberdeen in the same domain.
Mm-hmm.
So we always try to close the gap between academic practices and industry requirements. I saw your interesting collaborations with universities as well. So what we face, the most challenging situation when we have to train non-technical people and find the solution and bring this culture in line with what we want to implement in advanced digitization. So what would be your ideal solution to see that how we can overcome this challenge?
Very good question. I would like to refer to Yasir's presentation where he talked about the Maestro Hub solution. It's a startup that we internally incubated and they are now growing their solution globally. I think low-code, no-code probably is a good solution for this. So Yasir's Maestro Hub solution, for example, is a good case of low-code, no-code, which enables non-technical people, even frontline employees who don't have AI or data-related know-how maybe, to quickly generate dashboards and other types of insights from the data. So that was a very good example. Otherwise, we would spend maybe hours, hundreds of hours of training to those employees. But low-code, no-code certainly enables people to come up with quicker results. So therefore, I would focus on this type of solutions. Another good case from Siemens, for example, a key partner is Mendix platform, another low-code, no-code platform, which enables frontline employees to come up with quick applications themselves. So imagine what it would take to turn frontline employees to full stack developers. It is quite impossible, not practical. But if you provide them the right tool set, low-code, no-code tool set, then you enable them to do things, see results, and increase their enthusiasm. So my first answer would be definitely this one. In order to also create some excitement, what we are doing in Turkey is we are creating some hackathons to invite non-technical departments like finance, sometimes supply chain itself, to come up with experimenting methods with RPA solutions, robotic process automation solutions, and then to demonstrate to them they can come up with digital solutions themselves with robotic process automation, and they can create value for their own functions. So you are absolutely right. It doesn't make sense to upskill everybody, and it's difficult. But where it makes sense is to provide those low-code, no-code solutions and enable everybody through good mechanisms like RPA to contribute to the overall digital transformation of the company. So those are the two things that we are doing. We are promoting low-code, no-code solutions, and on the other hand, organizing things like hackathons internally within the company to get the non-technical departments to experiment themselves. Hopefully that makes some sense.
Thank you.
Can be together. So this could be one of the solutions that probably will work in future. This is one of the latest interdisciplinary approach that different organizations and universities are using to make sure we have more effective solutions and optimized solutions rather than we work in disjointed groups.
Silos.
So
I think this is probably one of the key takeaway messages. It is really key that teams work with each other, not against each other. Otherwise, digital transformation efforts most of them are bound to fail. So it's essential to promote that culture of internal collaboration. I think we all fully agree with that.
Thank you so much. Thank you, Efi. Thank you so much. You could always find more information about the Saudi Advanced Manufacturing Hub on SIDF's website. And you could also contact us if you want to reach Mr. Efi Erdem and their team at saudi.aimhub@sidf.gov.sa. I'd like to invite Engineer Abdullah Sayari, Project Studies Director, to appreciate Mixed's effort in their presentation today.
Thank you. Thank you, sir. Thank you. Thank you.
Represented by Mr. Efi Erdem, the Executive Director.
Thank you very much. Thank you.
Thank you so much.
Thank you very much, sir. Shukran. Shukran from our side. Thank you.
Thank everyone, and please, we have a short 5 minutes if you would like to network, and we have some refreshers outside. Thank you so much.
Thank you, everybody.